Hi, Stuart here with another video. Today we're going to talk about Redis. You can find my C# demo with some handy and sometimes hard to figure out Redis things on my Redis demo on my GitHub. So feel free to download or fork that. So my first power tip is do Redis development in Docker. Okay, here we are in PowerShell. Let's go ahead and start Redis in our Docker container. So this is Redis Insights. It's a free and incredibly handy little tool for getting both a GUI and your CLI all in one convenient place, and put some keys into Redis, and we can use this to explore our key space in all of our databases. We can use it to make edits, to do debugging, to do troubleshooting, to do all sorts of wonderful things. Built-in CLI, absolutely lovely. So I consider this an indispensable tool to help us use Redis. So first power tip that's often underused and unknown is that Redis actually comes out of the box with 16 database partitions. And so when you call get database all by itself, in whatever programming language, or even from the console CLI or from the graphical user interface, if you don't tell it any different, it just picks 0. And that's fine. By default, it passes in -1, and depending on how you set up your cluster, it could be something that isn't 0, but by default, if you pass in no arguments or the default argument, depending on your programming language, you get a -1, which the Redis clients interpret as being the default index, and the default index is typically 0. Which brings me to a pitfall and a good thing about the default index. And that is that if you have an application cache like ASP.NET and you have a little one-line piece of code in your startup CS that says, I want to make, this Redis instance at this URL my default application cache so I can share state between all my instances and improve the performance of my apps. Just let it be known that by default, it picks on partition 0. And so if you co-host other things in partition 0, you might have fighty-bitey IO, and that's not fun. So I typically reserve partition 0 for application cache. And even if I'm not using an application cache, I usually start using my database partition indexes at 1. And I get into the habit of always explicitly specifying my database partition every time I call get database, and I'm careful not to share my database objects outside my current execution scope so that I don't accidentally end up commingling keys, which is not a good thing. Which brings me to my next thing. IO in Redis is very, very clever. And I'll point out that if you're on a cloud provider, when you're provisioning your various versions of Redis, and we'll have future videos where we talk about troubleshooting Redis errors and other things, just a quick handy note, in addition to CPU and RAM and, the size of the key space, which is generally a reflection of the actual underlying storage that's allocated to Redis, and whether it's durable or not, we'll talk about that in a few minutes, you want to pay attention to the amount of network IO that is allocated to your Redis instance. And when you get errors on the client, when you're talking to Redis, especially in enterprise scenarios, the error message you get from the Redis server or the Redis cluster is incredibly diagnostically helpful. So much so, we're going to do a future video just on that. But one of the things that absolutely stands out is the instance of Redis you have provisioned has nowhere near enough network IO. And on Azure and AWS and GCP, the SKU that you pick for your platform as a service or infrastructure as a service Redis instance is going to have its network IO bound, sometimes in ways that are really underdocumented. And so it's always good to do a quick IO test, and you can do that very easily. But it's also good to hunt through the documentation for the instance you're picking. For example, we noticed when we were playing with Azure S instances or standard instances of Redis, and we turned on durability, that for whatever reason, the even numbered Redis instances, so S2, S4, had half the network I/O of the odd numbered Redis instances, S3 and S5. And that caused us some pain initially. So do be careful of that. I will also point out that using your Redis databases intelligently by separating out key value types. So don't put key fetches by string versus key fetches as sets versus key spaces that are hashes necessarily in the same database. You can if the number of keys is very small. If the number of keys is bigger, that's not such a great thing. Also, if you have different kinds of data with different access patterns, you'll find you're a lot happier in Redis if you divide them, treat each database like actually a little table, and put like data with like I/O profiles together. But again, it's good to consider the I/O profile of your particular data in Redis, and Redis will do its darndest to auto-optimize that for you, but you can make it easier by putting things with different I/O profiles in different databases. So for those of you who are coding against Redis in your favorite programming language, mine is obviously C#, you really want your connection multiplexer to be a singleton, but here's the big if, per instance or cluster. So if your application is connecting to multiple Redis-I, which is, I'm not sure the correct plural of Redis, you should definitely make sure that you're not reusing or sharing connection multiplexers. If there's any chance that you could be, you can take a little bit of a hit and make, as I did, a disposability wrapper around my Redis client. And you can go look at my Redis client to see how I did it. And in situations where I can't always count on there being a singleton connection multiplexer, I make sure that I do disposes to make sure that connections to databases are optimized. But the most optimized thing you can do, particularly if you're only connecting to one Redis instance, is on startup, allocate a static or whatever your language supports singleton connection multiplexer and use it all the way through all your executions. As I said before, seriously, avoid using index 0, except, of course, if it's the application cache, which is what it expects. And so just get into the habit when you're calling, this.connectionMultiplexer.getDatabase of setting the database index explicitly. And we talked about using strings, sets, and hashes appropriately. From a programming point of view, really think about, is this a hash table? Is this just a loose accumulation of things? Is this a set? And use the right algorithm, and you'll not only do fewer individual reads and writes, which will make it more performant, but logically, the way your data is organized in Redis will make a lot more sense. There are a couple of counterintuitive things about how Redis works. One of which is when you need to use get server versus get database. And there are very few times when you need to use get server, but when you do, it is splendid to know. It took me forever to figure out, Googling with Bing, that the way to delete all the keys in a database, the flush database thing, needs to be done by getting a Redis server instance, as in this code example. A lot of powerful features of Redis may not be explicitly in your particular library. I happen to love the Stack Exchange Redis library for .NET. There are really good libraries for Node and other programming languages as well, including some nice things for Go and Rust, and they're all splendid, but some of them are a little bit bare bones. But as long as they contain a way to do database.execute, you will be a happy camper, because Many of the cool, advanced, and performant features of Redis can be gotten through database.execute, and I typically wrap it in my own logic so that, I have a set of business rules about what I want to do, and I, hard code the operation so that I can't have a situation where I have an arbitrary execution of a command. I may have a semi-arbitrary expression that the command acts on, but by hard coding the commands themselves, I stay pretty much out of trouble. And of course, I use my favorite security tools to check to make sure I'm validating parameters and so on, which brings me to my next thing, which is that matches for keys in Redis are not quite regular expressions. Now, many of your beloved regular expression things work, like an asterisk for all, but there are some subtleties to how matches and keys for Redis work. So if you are going to need to do pattern matching on keys, then you should go look at the Redis documentation, and particularly those little notes in, I would call it medium gray, that they put underneath that. You should, read those and look at the examples, and then you should try them out, like write a unit test or an integration test, and make sure you absolutely understand how the matching patterns in Redis differ from both the Lucene syntax, which is used by the Redis search engine, or an extension of it is used by the Redis search engine, and the key matching language, which is much older, that is used for doing keys, for example, execution, to get back a list of matching keys. The other thing is Redis is, in the default, like you fire it up in my Docker desktop, I'm firing it up to be ephemeral. So when I stop it, it gets amnesia and all the key spaces are gone. But in the real world, you may very want to make it durable, which means that it's going to be writing to storage, depending on how you configure it. And that means your key spaces will survive reboots and outages and things like that. But if you're going to do that, or conversely, you're not going to do that, either way, you need to consider what happens when your cache restarts. What do you need to do in terms of restart and recovery, and make that part of your design. And then my last thing, and there'll be future videos on this too, it's way more than just a cache. I mean, a cache is my first use case for Redis. People say, what do you use Redis for? I go, application caching. But it's way more useful than that. It's a very capable object database, and it's got a multitude of sort of use at your own pace things. I particularly like Redis search, for example. And if you look at all of the different tools that it could replace, all the different components in an architecture, you can avoid, moving parts sprawl, where you have a lot of different technologies, the bucket of technologies that you sort of throw at it. And then you have to manage all these different instances, and you have to manage all these different technologies, and your developers have to learn all these different technologies, and they have to use lots of different APIs, and they have more different connections to more things. So now you worry about maybe running out of slots or whatever, and TCP/IP connections. They typically will have, really different I/O and connectivity behavior. So one of the things that I like about Redis is that, applying the Pareto rule, where I'd rather have 80% of what I want and code the rest and have fewer component diversity, I'll absolutely take that over having 20 different technologies in my solution. More videos are coming. My name is Stuart. Thank you for your kind attention.